Small mass is attached to the spring, rotates on a frictionless table as shown. If the tension in the string is increased by pulling the string, causing the radius of the circular motion to decrease by a factor of 2, the kinetic energy of the mass will be, okay, we have to calculate what will be the effect on the kinetic energy of the mass when the radius is halved over here. First of all, understand that the initial angular momentum will be equal to the final angular momentum by law of conservation of angular momentum. So initially now the mass was rotating with at a radius r. Let the mass be equal to m. So it will be equal to m. So L can be written as I1 omega 1 is equal to I2 omega 2. So over here initial angular moment, initial moment of inertia can be written as m r1 square into omega 1 is equal to m r2 square into omega 2. Now since the radius over here, since the radius is half, I can say that r2 will be equal to r1 divided by 2. So over here m and m will get cancelled out. r1 square omega 1 will be equal to r1 square divided by 4 into omega 2. So omega 2 will be equal to 4 times omega 1. Okay, the angular momentum over here will become the angular velocity will become 4 times the initial angular velocity. Now we have to calculate by what factor is the kinetic energy increased. Now the formula of kinetic energy over here is equal to half I omega square. So over here I can say that kinetic energy 1 divided by kinetic energy 2 will be equal to half I1 omega 1 square divided by half I2 omega 2 square. So basically it will be equal to, now I1 can be written as m r1 square into omega 1 square divided by m r2 square into omega 2 square. Now over here r2 is equal to half of r1, so it will be equal to r1 square divided by r1 square divided by 4, and this omega 1 square will remain as it is. Omega 2 square, since it will become omega 2 is equal to 4 times omega 1, it will be equal to 16 times omega 1 the whole square. It will become 16 times omega 1 the whole square. So omega 1 square will get cancelled out, r1 square will get cancelled out, 4 4s are. So over here I1 by I2 will be equal to, or the kinetic energy 1 divided by kinetic energy 2 will be equal to 1 by 4. So kinetic energy 2 will be equal to 4 times kinetic energy 1. So I can clearly say that the kinetic energy has increased by a factor of 4. Okay, the kinetic energy over here has increased by a factor of 4, which is equal to, which is over here, which is equal to option number D.